Yes, hello everybody. So today we are discussing a question based on EMI, electromagnetic induction. It's a very interesting question because it's teaching us a new method of generating electricity actually. So just look at the question. It says that the basic principle of magneto-hydrodynamic generators used for generating electricity is described here by a simple model that consists of a parallel plate capacitor immersed in a stream of conducting liquid in the presence of a uniform magnetic field B pointing perpendicular to the stream and parallel to the plates. Area of the each plate is given as A. Distance between the plates is D. Electrical conductivity of the liquid is sigma. Okay. The liquid flows between the plates with a constant velocity V towards the left side, they are saying. Okay. If resistance R is connected across the capacitor plates, okay, how much power will be dissipated, from where does this power come? So they are interested in the power dissipated. Now before that, the direction of velocity they said is towards left. So what I have drawn here in this diagram is actually wrong. The velocity is inwards like this. Okay, the fluid is entering in and it is leaving from the other side. It's actually coming out from the other side, the fluids. And magnetic field, they are specifically saying that magnetic field is acting like this. In the question they're showing that, okay, it's coming from the bottom and going through vertically outwards like this. Okay, something like this. Okay, all right. Now, because of this magnetic field available when a fluid, a conducting fluid specifically mentioned, when a conducting fluid is passing through between these two plates through this magnetic field, because of this, there'll be a force applied on the conducting fluid. So, can you imagine this force now? Like, which direction it will be? Magnetic field is upwards. The fluid is moving not this direction, but that direction. So, I rotate like this. And when I do that, I find that the force is acting inwards, right? Inwards means any fluid which is moving in this direction, the positive charge of those fluids would be accumulating on this side of the plate. And all the negative charges would be now accumulating onto this side. Whichever direction the positive charge experiences the force, opposite to that the negative experience. So we can say that this is how the motion has happened. The magnetic field upwards, the motion of the liquid, the conducting liquid in that direction, and the force is experienced in this direction because of that positive this side and negative this side. So we can say the force experienced by the magnetic field FB is equal to QVB. Whenever a moving charge passes through a magnetic field, it experiences this force, right? Actually, it's QVB sine theta, but if you look at the angles, the angle between the velocity and the magnetic field is 90 degree. So sine of 90 would be 1. So this is the magnetic force experienced by the charge. Because of this magnetic forces, the charges got split into these two locations. This distance between the plates, they're giving it as D. So they got separated by that distance. Because of that, now there is also an electric force that is generated, and the electric force is given as Q into E. This is the electric force. So until when will the charges be moving? If you ask that, we can say that the charges would be moving until which an equilibrium has been attained. That is, electric force becomes equal to the magnetic force. So electric force becomes equals to magnetic force. Until then, there will be this separation, right? So this is you. By why I'm doing this is by using this, I'll be able to find electric field generated, and by using electric field, I'll be able to find out the the potential generated. See, like right now, you can see that Fe is nothing but QE, and the magnetic force is nothing but QVB. The Q gets cancelled. Basically, E is equals to VB, where V is the velocity and B is the magnetic field. So by doing this, I have found out the electric field that is generated between the two conducting plates. And this electric field is generated in how much distance? D distance. Which direction the electric field would be, you think? This is positive, this is negative, so electric field should be acting in this direction. This is how the electric field has been generated, and that electric field is generated for D distance. So that's why we can say the voltage or the EMF, you can call it as anything, This generated is nothing but E into L. That L is the distance for which electric field is there, and that's D. So I'll be getting BVD as the EMF induced. Once you get the EMF, now you have to find out the power. Now power I can find by using the formula power is equal to I square into R. They are interested in power generated in that external resistance. That's why I'm writing it as the current passing through that into the resistance. So I square into R. For that I need the current. So current can be easily found out as I is equals to V by R. Question is which R? The total R. What is the total resistance in the circuit means? Yes, the resistance is there, capital R in the circuit, obvious resistance, but also they said that the liquid is conducting with a conductivity of sigma that they have given. So we have to use that conductivity, right? In which direction the charges are moving? We can say that negative charges would be moving in this direction like this way the negative charges would be moving. So how much distance the negative charges have to cover? D. Through how much area the negative charges would be moving? Through this much area, plate area, through that much area. So I can find out the resistance produced by the liquid. I can write it here, for example. The resistance produced by the liquid is nothing but rho L by A. Instead of rho, they have given the conductivity as sigma. And what is the L, the distance it has to travel? D. And the area given in the question is A. So basically the resistance produced by the liquid is D by sigma A. This much is the resistance produced by the liquid. Now using that resistance, I can find the total resistance in the circuit. The total resistance is nothing but how much V first of all. The V we got it as BVD, where V is the speed or the velocity with which the liquid is moving, and divided by total resistance. This resistance plus resistance by the liquid, they're all connected in series, right? So RL plus R, that's my equation. So I'll be getting it as BVD divided by RL is nothing but D divided by sigma A plus R. This is my current. Once I get the current, I can find the power now. The power would be given as P is equals to I square, which is B square V square D square divided by this square, that is D by sigma A plus R whole square times R. I square R. That's what I have written. If required, you can just take the LCM of this and that would be the end of it. So you can say power is B square V square D square. And then when you take LCM, the sigma square A square will also come up divided by D plus sigma A times R whole square into R. This becomes the power dissipated. This is the total power dissipated in this location. Now in question, they're also asking one conceptual thing, that from where did this power come? Because conservation of energy has to be valid. Power cannot be just randomly created from anywhere. So they're asking from where are we getting this power that we have got as electric power, like heat power that we are getting finally. From where we are getting? So answer to that is very simple. Somebody or some entity is actually moving this fluid, right? See, when the fluid is actually moving in this direction, the fluid contains, let us say, positive charges. For example, I'm saying positive charges. Don't you think that the positive charges would be repelled by this positive? So there will be some repulsion that is experienced by this charges as it moves, right? To overcome that repulsion, you will have to provide some kind of a mechanism like a pump or something to continuously move this liquid in there. Okay, so motion of the liquid is maintained by a pump to which you are actually supplying some power. That power is now getting converted into electricity, which is later getting dissipated here as heat, like that. So that part of the question we have answered, like from where is this power coming? I hope you have understood the question. It's a very interesting topic because a new method of generating electricity you have studied by using some conducting liquid. If you pass it through between two plates and magnetic field is available, then you can produce the current using that. So this method is very interesting to know, and the process is very simple. What we have done is nothing more than NCRT. Actually, it's NCRT concept only we have used, and we have found out the final answer of power. I hope all of you have understood it. We shall stop here then. Thank you.